Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions based upon the basics of moving coil galvanometer, current sensitivity, voltage sensitivity and figure of merit. Okay, so to understand this video, I hope so you have seen the previous video also. Okay, so let's start the video. First question is here. For full scale deflection of total 50 divisions, 50 millivolt is required in galvanometer. The resistance of galvanometer if its current sensitivity is 2 divisions per milliampere. Okay, so we have to calculate what resistance. So remember that here, if I talk about here the current sensitivity, so current sensitivity means IS. It is given how much here? Let's say here 2 divisions per milliampere. So you can see here 2 divisions per milliampere. But I want in a SI unit by seeing the options. So we can write here, see 2 divisions. Milliampere means 10 to the power minus 3 ampere. Is it? So we can write here 2 into 10 to the power 3 divisions per ampere. Okay, this is the unit. After that, if I calculate here the voltage sensitivity. So voltage sensitivity means what? Divisions per volt. Okay. So see here how many divisions are there? 50 divisions are there. 50 divisions. And how many voltage is there? You can see 50 millivolts. So we can write here, see 50 into 10 to the power minus 3 volt. Is it? So after that, what other things can be cancelled out? We can see here this 50 and this 50 is cancelled. 10 to the power minus 3 will go up. So I can write here 10 to the power 3 divisions per volt. This is the current sensitivity. This is what? Voltage sensitivity. And after that, remember that here the relation between resistance, current sensitivity and voltage sensitivity is this: R equal to IS by Vs. Okay. In Ohm's law, we used to write R equal to V by I. But in case of sensitivity, it will be R equal to IS by Vs. Okay. So what is 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 given? You can see very well. 2 into 10 to the power 3, and here what is given here? 10 to the power 3, everything in SI unit. So 10 to the power 3, 10 to the power 3 is cancelled, and we can write here what? 2 ohm. Same kind of questions came in a NEET 2018 also. Okay, can you see here? Now students, let's move to the next one. Here you can see the question is, in a moving coil galvanometer, 2 moving coils M1 and M2 have the following parameters. So here they have given, you can see resistances, number of turns, area of cross sections and magnetic fields, everything in SI unit. After that, let's see. Assuming that torsional constant of the springs are same for both coils, what will be the ratio of voltage sensitivity of M1 and M2? Okay. So here we should write the formula of the voltage sensitivity in terms of a number of turns and all. So remember that here this voltage sensitivity is given by NAB by K into R. N is number of turns, A is area of cross section of coil, B is the magnetic field, K is the torsional constant and R is the resistance. In the question they told torsional constant, anyhow they have given same for both of them. So from here we can write here Vs is directly proportional to NAB by R, because what is there? K is constant. Okay, so hence if I write here the ratio voltage sensitivity of instrument M1 to the voltage sensitivity of the instrument M2 is given here what? You can see very well, number of turns directly proportional, so N1 by N2, area of cross section directly proportional, so A1 by A2, magnetic field also directly proportional, so B1 by B2. But resistance is the inversely proportional. So what I will write here? R2 by R1. Okay. Now after that we have to put here all these values. What is N1 by N2? You can see very well 15 by 21. Okay. We'll write here one by one. It is given here 15 by 21 into what is A1 by A2? You can see here. When you will take the ratio, what will happen? 10 to the power minus 3, 10 to the power minus 3 will cancel out, and we can write here A1 by A2 na. So see here, this is A2. So A1 by A2 will become what here? 3.6 by 1.8. Okay, see 3.6 by 1.8. Okay. B1 by B2. What is B1 by B2? Let's see from here, 0.25. This is B2, 0.25 by 0.50. 0.25 by 0.50 into R2 by R1. We have to make it here reverse. So R2 by R1 will become here what? 7 by 5. Is it? So see here, I will write here 7 by 5. Now let's see what are the things can be cancelled out here. Now let's see here. So we can write here, see, 3 5 ja 15, 3 7 ja 21. This decimal went. So let's see here, 5 by 7 into this will be 36 by 18. So 36 by 18, when you will simplify this will come 2 by 1. Here what will happen that here, see, this decimal went. 25 by 50, what will become here? 1 by 2 into, and here anyhow what is coming here? 7 by 5. Let's see what other things can be cancelled out here. This 5 cancel, this 7 cancel, this 2 and this 2 also cancel. Okay, so you can see very well it is coming here what? Just 1, or what we can tell here, 1 by 1 or 1 is to 1 here. Is it? Can you see very well? Very simple question based upon the formula. So what is the answer for this question? The answer for this question is what? 1 is to 1 here. Is it? Very basic question, and this is also even N2. Okay. Next one, let's see. Next question is students. So here you can see the next question is, for a moving coil galvanometer, the deflection in the coil is 0.05 radian when a current of 10 milliampere is passed through it. If the torsional constant of suspension wire is 4 into 10 to the power minus 5 Newton meter per radian. Here they are given deflection in a radian, and here also they have given, you can see the unit here also radian. Is it? That is very, very important. Then only units will adjust. The magnetic field is 0.01 Tesla. The number of turns in the coil is a 200. The area of each turn in centimeter square is how much here? Okay, so very basic formula based question is there. Let's note down the first data. So here you can see very well deflection means a theta. What is given here? 0.05 radian. That means I can write here 5 into 10 to the power 2 radian here. Okay, next one, let's see here what they have given. The current what is given here, if I talk about here the current I value is given here 10 milliampere. So 10 into 10 to the power minus 3. So I can write here just 10 to the power minus 2 ampere. After that, torsional constant what they are giving here, K value you can see very well, 4 into 10 to the power minus 5. And unit is what? Newton meter per radian. Okay, and next one, let's see here. Magnetic field value what is given here? Magnetic field is given 0.01 Tesla, or we can write here 10 to the power minus 2 Tesla. And the number of turns, capital N, they have given here 200. So we can write here 2 into 10 to the power 2, no units and all that. Okay, so here we have to remember one formula. The formula is what here? Now, in a previous video, I have taught you restoring torque is equal to the deflecting torque. Okay, so deflecting torque what used to be, see, NIAB is equal to K theta. This formula is very, very important in a MCG. Okay, so from here, students, when we write here the what they are asking, the area of each turn. So area means which letter? Capital A. So we can write here capital A means K theta by NIB. Okay, K theta by NIB. After that, we'll put here the data and all. K theta what is given here? Let's say here K is here 4 into 10 to the power minus 5. Now we have to just put here the values. 4 into 10 to the power minus 5. Theta what is given here? 5 into 10 to the power minus 2. Okay, by N value what is given? 2 into 10 to the power 2. And I current what is given here? 10 to the power minus 2. Okay, and magnetic field what is given here? Let's see here 10 to the power minus 2. Okay, so in this, let's see what are the things can be cancelled out. So from here we can see very well this 10 to the power minus 2, 10 to the power minus 2, and this 10 to the power 2 is cancelled. Okay, then we can write here what? See, 2 2 is 4. So this will become here, see, 2 into 5, that means 10. Okay, and let's adjust the power. See here. So this 10 to the power minus 2 and this 10 to the power minus 2 is also cancelled. So it is coming here 5 into 10, and it is becoming here what? See, 10 to the power minus 5 is also pending. Now just simplify this, very easy. Then what this will become here? It will become here 10 to the power minus 4. Unit is what? Meter square. But in the question they are asking what in which unit? Centimeter square. So 10 to the power minus 4 meter square means 1 centimeter square. Okay, very basic thing. So what is the correct option is there? The correct option is here, option B is the answer. See here, very easy question. Okay, great. Now let's move to the next question. The question is here, very basic question. See, given below are two statements are given. No? So let's see what is the first statement. Statement 1 is here, if the number of turns in the coil of a moving coil galvanometer is doubled, then the current sensitivity becomes double. Okay, so for that we should know the formula of the current sensitivity. What is the current sensitivity formula? It is given here NAB by K. Okay, so here what is happening that here this current sensitivity is directly proportional to N. Okay, so other things ABK, it's not related to that. No. So what will happen that here the number of turns, what is happening, they are making the number of turns double, and they are telling current sensitivity will also double. So we can tell very well when this will become double. No? So this will also become double. Why? Because both are directly proportional. If here I am writing here a 2, so this will also become 2. Okay, so statement is right or wrong? Statement is right. Okay, so see here, this statement is right only. Okay, next one, let's see here, what about the statement 2 here? Let's see statement 2. Statement 2 is here, let's see, increasing current sensitivity of a moving coil galvanometer by only increasing the number of turns in the coil will also increase its voltage sensitivity in the same ratio. So they are telling if the number of turns is becoming twice, current sensitivity is becoming twice, but voltage sensitivity will also become twice. No. Why? Because behind this one basic reason is there. What is the basic reason? Remember that here the voltage sensitivity formula is what here? This is given here, C, NAB by KR. Okay, so remember that one thing, this N is related to R. What can I tell here? When I will write here the voltage sensitivity, it is directly proportional to N and R because N and R is interrelated. Okay, because in last video also I have told you resistance formula is given here, R equal to rho L by A. L means related to the number of turns. Okay, so I can write here rho into N by A. So what will happen that if in case you are increasing the number of turns, okay, so resistance will also increase in the same fashion. If in case you are making number of turns twice, then resistance will also become twice. So what about the ratio? The ratio will be constant. Okay, so this Vs is independent of N and R. The moment you will change N, R will also change in the same fashion. That means here what will happen that here, if in case you are making here, for example, this number of turns twice, so what will happen that this resistance will also become twice, and what will happen that here this 2 and 2 will cancel out, then again you will get here N by R. That means what is happening, by making the number of turns twice, current sensitivity will become twice, but voltage sensitivity, it will be unchanged. It will not change, as I have told you very well. So what is happening, this statement 2 is wrong. So you can see very well statement 1 is correct and statement 2 is what? Wrong. So let's see here which options are correct here. When you will see here all the options and all that, you can see very well option C. Statement 1 is true, but statement 2 is what? False. Okay, remember that. Next one, let's see. The question is very basic question here. The current sensitivity of a galvanometer can be increased by, again some options are there, decreasing the number of turns, that means N they are talking about, increasing the magnetic field, B they are talking about, decreasing the area of coil, A they are talking about, decreasing the torsional constant of the spring, K they are talking about here. Okay, so for that again I am telling you what is the current sensitivity formula. You should know the formulas. The formula is NAB by K. Okay, so you can see very well this current sensitivity is directly proportional to the magnetic field. So when this magnetic field will increase, current sensitivity will increase. Okay, so decreasing the number of turns, no, we want to increase the current sensitivity. That means not N, because to increase the current sensitivity, N should increase, A should increase, and B should also increase. Okay, so what is there? Increasing the magnetic field. Option A is wrong, decreasing the number of turns. Option C, decreasing the area of cross section of the coil, wrong. Now after that, if we talk about here the torsional constant, so for increasing the current sensitivity, the torsional constant should be decreased because they are what? In denominator, inversely proportional. That means we can tell decreasing the torsional constant of the spring. So here which options are correct? B and D is correct. So choose the most appropriate answer from the options given below. So let's take here which options are there. We know very well what is correct here. B and D is correct. So we can see very well where is the B and D. So see here. Option B and D is correct. In this way only we can increase the current sensitivity. Okay, great. Now let's see. The next question is here. The question is here. See. A galvanometer is used in laboratory for detecting the null point in electrical experiments. If on passing a current of 6 milliampere, it produces a deflection of 2 degree. Its figure of merit is close to how much? And here you can see the options: ampere per division, ampere per division, ampere per division, ampere per division. There is no options like ampere per radian. So remember that here, if we talk about here the current sensitivity is having the 2 units. We can write here what? Current sensitivity, na? Is it? So 1 minute here. No, here they are telling what here? It's a figure of merit is close to figure of merit. Okay, so in case of figure of merit, what will happen that here? Figure of merit is very well connected to the current sensitivity. Figure of merit is just reciprocal of the current sensitivity. Here we can write here what? I by theta. Current sensitivity theta by I, figure of merit I by theta. So if I talk about here the units and all, the units can be what? Ampere per division or ampere per radian. Both can be the units of the figure of merit. Okay. After that, remember that here what are the units are there? Ampere per division. There is no unit like ampere per radian. So here this 2 degree no need to convert into radian because options are not like that. So anyhow, this unit is not at all possible because they are not asking in a radian. Otherwise, we will multiply with pi by 180 degree. We will convert into radian and we will get it. But here we want the answer in radian. So whenever in the question we want the answer in a divisions and all, and they are giving degree. So by default we can consider just 1 degree is approximately equal to, or 1 degree is equal to 1 division. Different MCGs will be having the different calibrations, but by default, if options are not there in a ampere per radian, no need to convert. Options are there in a ampere per division. So what we'll consider? We'll consider 1 degree is equivalent to what? 1 division. Then only we can solve very easily this question. Otherwise, mistake will happen. So this figure of merit will become what here? I by theta. What is I? You can see very well 6 milliampere. That means 6 into 10 to the power minus 3 ampere. And how many? Deflection is there 2 degrees. So this is 2, and what I am telling you, this degree I am taking as a whatever division. Okay. So what this answer will come here? Answer will come here 3 into 10 to the power minus 3 ampere per division. So which option is correct here? You can see very well the correct option is here, option D. Okay. And just for the basic understanding, I am telling you, if in case the options are there in ampere per radian, then what you will do? See here please, you will write here like this. See, 6 into 10 to the power minus 3 ampere, and this theta you have to convert into radian. That means you will write here like this, 2 degree into pi by 180 degree. Okay, and then only it will come here in radian. Ampere per radian is there. Okay, see, I'll just separate it here. This is here. Okay, so if in case they ask ampere per radian, you have to go like a yellow color step. But here options are there in ampere per division. So what I have taken? 1 degree, I have taken 1 division, and then I have got this option. Kindly see very well, don't get confused. Okay, great. Now students, let's see the next question is here. The question is here, see, a moving coil galvanometer has a coil with 175 turns and area 1 centimeter square. It uses a torsion band of torsion constant 10 to the power minus 6 Newton meter per radian. Again, the coil is placed in a magnetic field B parallel to its plane. The coil deflects by 1 degree for a current of 1 milliampere. The value of B in Tesla, how much? If little bit you will think, you can see very well here the unit is used here radian, and here what is used here? Degree. That means we have to convert this degree into radian, then only units will be balanced. Okay. So first let's note down here the data. So let's see the data what is given here. Number of turns, it is given here 175. 175 turn is there. Next one, what is given here? The area of the coil, what is given here? 1 centimeter square, that means 10 to the power minus 4 meter square. Next one, what is given here? The K value, the torsional constant value, it is given here what? 10 to the power minus 6 Newton meter per radian. Okay. After that, coil is placed in a magnetic field parallel to its plane. And you know very well here, in this chapter there is the area vector is involved. So whenever area vector is involved, because magnetic moment, the formula is M equal to NIA. Magnetic moment is the vector quantity, and area vector is also see M equal to NIA in this chapter. So whenever area vector is involved, area vector is perpendicular to the plane of the coil. So in this situation, they will tell here the coil is placed in a magnetic field parallel to its plane, But anyhow, what will be there? The angle will be how much here? 90 degrees. Remember that here. Theta how much here? Parallel to its plane. That means what will happen that here? The angle will be 90 degrees there. Okay. So what we can write here? The coil deflects by, okay, this one here, parallel. This alpha I will tell you. What I will tell you? Alpha, not theta. Theta is the deflection. Okay. This is the alpha is there. Alpha what is given here? 90 degrees there. Na? This is the angle between magnetic moment and the magnetic field. Little bit doubt is there. You can see very well. This is the plane of the coil. Okay. And the magnetic field is parallel to the plane of the coil like this. Okay. So if I talk about here the area vector is like this, and it will make how much angle? 90 degree. Is it? So remember that here alpha is 90 degree, and after that the deflection what is given here? Let's say here this is the deflection. Theta is given here what? 1 degree. That means 1 degree into pi by 180. Then only it will become here what? Pi by 180 radian. Okay. Now all the things are okay. Now what is the formula? Remember that the formula is given here. The deflecting torque is equal to what? Restoring torque. Deflecting torque formula. What is the formula? Remember that here. Torque formula. NIAB sine angle between magnetic moment and the magnetic field how much here? 90 degrees. So here please. Sine 90 degrees. Restoring torque what is there? K theta. Okay. Sine 90 anyhow 1 in the question what they are asking? Magnetic field B. Okay. So what we can write here? Magnetic field. Magnetic field will become here see K theta by this will become here what? NIA. Is it? K theta by NIA. Now very easy. We have to just put here the values. That's it. Okay. So let's put here the values. K value what is given here? K value you can see 10 to the power minus 6. Okay. Minus 6 into theta value. Theta deflection. Pi by 180. Pi by 180. Okay. NIA. N what is given here? 175. 175 into I. NIA is there. Na? Current anywhere is given here. NIA because they are asking magnetic field. Current is required. The coil is placed in a magnetic field. The coil deflects by 180 for a current of 1 milliampere. See the current is given here what? 1 milliampere. So here also this data is there. Current data how much is given? 10 to the power minus 3 ampere. Okay, because that we require here. 10 to the power minus 3 into area what is given here? Let's see here area is 10 to the power minus 4. Okay. So after that we will just simplify this. So you can see very well now. So here what we can tell here, see this is minus 3, minus 4, minus 3, minus 4 how much here? Minus 7. 10 to the power minus 7 when it will go up, it will become 10 to the power 7. 10 to the power 7 into 10 to the power minus 6. What this will become here? Just this will become here 10. So we can write here, see 10 into pi by 180. Pi means 22 by 7 into 1 by 180. Okay, and here what this will become here? Let's see here 175. Now let's simplify this. So what this will become here? See this 0 and this 0 is cancelled. Okay, and we can write here, see 2 1 ja 2, 2 1 ja 2, and here it will become here what? 2 9 ja 18. We are just simplify this here. So what this will become here? Let's see here. This is the 11. This is the 175. This 9 is pending, and after that what is there? One more thing will be there. This 7. This 7 is also pending. See here this 11 came. This 9 pending, this 7 pending, and this 175 is pending. Okay. After that we have to just do here the somewhat rough calculation. So here what this will become here? You know very well here. This is 11, this is 175. So when you will simplify this, 11 into 16 how much? 176. But here what is given here? 175. So this 175 approximately I can consider 176. So this will become here 1 by this I will write here approximately 16 into 9 into 7. Okay, and after that, no, from here I will just take here. So when you will simplify this things, it will become here 1008. Okay, then this thing approximately I can write here 1 by 1000, and this will become here what, 10 to the power minus 3 Tesla. Okay, so 10 to the power minus 3 Tesla will come here. Okay, see here, this thing I will keep it separate, and from there we have went here. So 10 to the power minus 3 Tesla, which one is the option is correct here? You can see very well, the correct option is the option D is the answer. Is it? See here. Okay, so students, I hope so this video based upon the current sensitivity, voltage sensitivity, figure of merit and basics of the galvanometer like a deflecting torque, restoring torque is very clear to you. Keep studying, keep going.